All right, our final operations with radicals is going to be when we divide. So first thing I want to remind you of is that, remember when we were multiplying and we had two radicals that we were multiplying together? We said, hey, let's put them under the same radical and multiply them together. And then, of course, we said, but after we do that, we can take out perfect squares. So I could say 150 is square root 25 times square root 6, which is 5 square root 6 for my final answer. Big thing I want us to remember, though, the big part of that I want to focus on is this piece right here. We're going to basically do the same thing with dividing. We're going to say that, hey, if we have two separate radicals, we can, and there's division, we can put it together and divide all of that under the same radical. Or even more importantly, we can say that, hey, if we have a fraction underneath one radical, we can split that up and give both top and bottom of the radical, or of the fraction, its own radical. This is something that I really want to point out. Notice I highlighted it. I highlighted it because it is so important, and I see students forget to do it all the time. We're dealing with fractions here underneath a radical, so as always, first reduce. So let's look at some examples. I think I have 4 examples total. These do go pretty quick. Let's say I have radical 25 over radical 81. First thing I do is I check, can 25 and 81 both be divided by anything? The answer is no, so next thing I'm going to do is use this product up here and say that means I have the square root of 25 over the square root of 81. Well, guess what? I know what the square root of 25 is. It's 5. I also know what the square root of 81 is. It's 9. So I get a final answer of 5 over 9. Looking at example 2, I have 2 times the radical square root of 4 over 9. First thing I'm going to ask myself, is there anything that both 4 and 9 can be divided by? I think about it for a second and no, there's not. So next step I'm going to do is I'm going to just carry that 2 over and say 2 times the square root of 4 over the square root of 9. Well, that gives me 2 times the square root of 4, which is 2, over the square root of 9, which is 3. I know that when I multiply fractions, I multiply straight across the top and straight across the bottom. That's technically 2 over 1, giving me an answer of 4/3. Looking at my next 2 examples. First thing I'm going to do on example 3 is ask myself, is there anything that both 24 and 3 can be divided by? The answer is yes, they can both be divided by 3, giving me the square root of 8 over 1, which I know is the same thing as the square root of 8. Again, I check to see if I can simplify that, and the answer is yes. 8 is the same thing as the radical 2 times 4, or as I like to write it, 4 times 2, because I like to put the perfect square first. Why do I break it into a perfect square? Because I can simplify my perfect square and get a final answer of 2 radical 2. Looking at my 4th example, this would be a good one for you to try. It's the last example in the video. This is a pretty quick video. So if you want to try this, go ahead, pause the video, see if you can't come up with an answer. All right, now that you've tried it, I'm going to go ahead and say, first thing I check for is there anything both top and bottom can be reduced by? Well, I know 48 and 4 are both divisible by 4, giving me the square root of 12 over 1, which again is the same thing as just the square root of 12. I do not need to put 1s on the denominator. I do, however, need to write them if they're in the numerator. From here, I ask myself, does 12 have any perfect squares in it, or am I done? The answer is yes. 12 is the same thing as radical 4 times 3. I know it's 2 times 6 as well, but neither of those are perfect squares, so I don't care. Only care about perfect squares. I can break this into square root of 4 times square root of 3, which gives me a final answer of 2 times the square root of 3. Since square root of 3 is not a perfect square, and there are none in there, I can go ahead and stop there. That's it. That's how you divide with radicals and numbers.